Hey there, and welcome. Have you ever wondered how a scientist's little hunch, maybe jotted down on a notepad, eventually becomes a rock-solid fact that literally shapes our world? Well, today, we're going to trace that exact journey, from a simple what if, all the way to the established scientific knowledge we rely on every single day. All right, let's jump in.
You've heard it a million times, right? Someone dismisses a huge idea by saying, "Oh, that's just a theory." But here's the thing. In the world of science, a theory is about as far from just a guess as you can get. So how exactly does science build that bridge from a simple question to a powerful, factual explanation? That's the big question we're diving into.
So here's our game plan. We're going to see why science is way more than a guess, and then we'll get into the absolute bedrock of it all, the power of repetition. After that, we'll clear up the classic mix-up between a theory and a law, put it all into practice with a pendulum test, and wrap up by seeing why prediction is the ultimate goal.
Okay, first stop is probably the single most important part of this whole process, and honestly, it's the one we often forget about. It's all about repetition. This isn't about getting it right once, it's about getting the same result over and over and over again.
Think about it. A one-time miracle result in a lab? It's interesting for sure, but it's not science. Not yet. Science demands that your results can be checked and confirmed by anyone, anywhere on the planet. This obsession with consistency and reliability is what gives scientific knowledge its incredible strength.
It really breaks down like this. First, you notice something interesting happening. Then, you come up with a hypothesis, which is just a fancy word for an educated guess. To explain it, you run an experiment to see if you're right. But here's the secret sauce, step 4. Repeating that experiment and getting the same result, time after time. That's what turns a hunch into hard evidence.
So, you've got all this solid, repeatable evidence? Now what do you do with it? Well, this is where two of the most important and maybe most confused words in science show up: theories and laws. So let's clear this up once and for all. Okay, a scientific law is basically a description of a pattern we see in nature. It doesn't try to explain why it happens, but it tells you with amazing accuracy what is going to happen in a given situation. It's like the ultimate rule book for one specific thing.
Now, a scientific theory, this is the big one, is the complete opposite of just a theory. It is a massive, well-supported explanation for why that law works the way it does. It's built on a mountain of facts, countless observations, and confirmed tests. And here's the really cool part. It's not set in stone. If new, better evidence comes along, a theory can be updated. That ability to self-correct is what makes science so incredibly powerful.
So look at them side by side here. They're like two perfect puzzle pieces. The law is the what. It describes what's happening, often with a neat math formula. The theory is the why or the how. It's the big picture explanation that ties all the facts together. They don't compete, they work together.
All right, enough with the definitions. Let's make this real. We're going to walk through a simple, practical experiment that proves all these points. The good old pendulum test.
So picture this. We just have a weight tied to a piece of string. We pull it back, we let it go, and it just swings back and forth, back and forth. Our job as scientists is to watch it, measure it, and, you guessed it, repeat, repeat, repeat. Always looking for those consistent patterns. Now, after we do this a whole bunch of times, two really key things pop out. First, if you make the string longer, the swing takes more time. Makes sense. But the second finding is the one that's kind of wild. Changing the weight on the end of the string, it doesn't change the swing time at all. A little pebble or a heavy rock, they swing at the same rate. And this isn't a fluke. It happens every single time. That is consistency in action.
And there it is. That's the moment it clicks. All those repeated measurements, all that reliable data, it gets distilled down into a scientific law. We go from a bunch of separate observations to one single powerful formula. That formula is the law of the pendulum, and it precisely describes the what, telling us exactly how any pendulum will swing.
So this brings us to the final, and honestly the most powerful piece of this entire puzzle. Why go through all this trouble? Why do we need laws and theories? Well, the answer comes down to one word: prediction. You see, describing something that's already happened is useful, but the real acid test of scientific knowledge is whether you can reliably predict what is going to happen. That is what separates true understanding from just telling stories.
And this chart just nails it. Being able to describe something, great. Being able to explain it, even better. But being able to predict an outcome with precision, well, that's the whole ball game. That's the ultimate proof that you really, truly understand how a piece of the universe works.
let's circle back to our pendulum. Because we have a law that can predict its swing with near-perfect accuracy, we can build things with it, like incredibly precise clocks. For hundreds of years, that predictable swing was how we kept time. That isn't just some abstract idea, that is the power of prediction, building the world around us.
So, from a simple observation to a predictable law, we've seen how science builds knowledge you can count on. It's a process that's happening all the time, always trying to turn today's hunches into tomorrow's facts. And it really makes you wonder, doesn't it? What deep mystery that we see every single day is just waiting for the next great theory to come along and explain it all.